Hey, what's up, Algebra 2? It's Ryan. Today we're going to be going over complex numbers. So, if you remember in the last lecture I did on solving quadratics by square roots, I mentioned this number I. And so it's kind of an elusive concept, but we're going to be going over that today, diving into diving into imaginary numbers, complex numbers. And you can see some of our objectives are going to be to simplify square roots using imaginary numbers and also perform operations with complex numbers. Okay, so let's start with this problem. We have 8a squared minus 7 equals negative 39. So first, let's try to solve this, okay? So what I would do originally is I'd add 7 to both sides, right? And we'd get 8a squared equals negative 32. Then we divide both sides by 8. We get a squared equals negative 4. Then we take the square root of both sides. But we can't take the square root of a negative number, right? Because by definition, a square is a number multiplied by itself. So when we multiply a positive by itself, that's a positive times a positive, and that gives us a positive number. But if it's a negative, we multiply a negative by itself, so negative times negative, that also gives us a positive number. So we can't have a negative under the square root with it being real. So that's why there are no real solutions, if that makes sense. You can write this out. I'm not going to, but I explained it in word form right then. So let's graph this. Let's write this out in standard form. So that means moving this 39 over to the other side. That's going to give us, I'm just going to say y equals 8a squared. And then we add 39 to negative 7. We get plus 32. So if we have a graph, it's going to look something like this, right? We have a positive coefficient in front of a squared. So that means it's going to open up. And our y-intercept is 0, 32. So it's going to look something like this. And so what I want you to think about is we talked before in the very beginning of this unit about quadratics. What are solutions on a graph? Well, they're going to be our x-intercepts. So whenever we intersect this axis, but you see that we never intersect this axis, right? This parabola never crosses over our x-axis. So that's why we're not going to have any real solutions in this problem. But we will still have imaginary solutions. And that's what we're going to be doing in today's lecture. Okay, so back to this problem. We had the square root of a squared equals the square root of negative 4. I'm going to switch that up. So the square root of a squared is just going to be a. And instead of saying the square root of negative 4, I'm going to say the square root of 4 times the square root of negative 1. We said before we can't have the square root of a negative number. But what we're going to do is we're going to assign this imaginary number I to be equal to the square root of negative 1. Okay, and then that's how we're going to deal with that. So we would say the square root of 4 is 2. And the square root of negative 1, we're just going to say I. So I is always going to stand for the square root of negative 1. Okay, let's solve some other problems. So for example here, we're taking the square root of negative 121. Let's split that up into the square root of 121 times the square root of negative 1. The square root of 121 is 11. We said the square root of negative 1 is I. Okay, perfect. Now here, I'm just going to disregard the negative. We just look at the 32. What are some perfect square factors of 32? Well, 16 is a perfect square and it's a factor of 32. So I'm going to write this as root 16 times, we need root 2 to get to 32, and then we also have that negative out in front. So we're going to have root 16 is 4, root negative 1 is I, and then times root 2. Sorry, my bad. Times root 2. And that's how we'd solve that. Okay? Now we're going to start multiplying some values. So first, what I would do here, let's try to simplify, or you know what, let's multiply 6 and 42. So 6 times 42, let me get my calculator out real quick. 6 times 42 is going to be 252. So I'm going to write 10 times root 252. And we still have this negative, so I'm going to say times root negative 1. And 252, let's think of some factors. So, for example, I'm just going to say 4. Well, 240 is a multiple of 4, right, times 60. Then we have 12 more. So that's going to mean 2 and 4 or 3 4s fit into 12 more. So it's going to be 63. Sorry, I don't know if I explained that well. 252 divided by 4 is going to be around 63, I believe. Let's just check that. Yeah, okay, perfect. So we're going to factor out of root 4. We're going to say 10 times root 4 times root 63 times root negative 1. And now we have to think, can we factor anything more out of 63? Well, we can do factor out of 9. So this is getting kind of messy. It's not very organized, but it's all right. We're doing 10 times root 4. Then I'm breaking up this root 63 into root 9. And then 9 times what equals 63? 9 times 7. So I'm going to say 9 times 7 times square root of negative 1. Well, let's just evaluate all this. Root 4 is 2, so we're going to have 10 times 2 times square root of 9 is 3 times, and I'm just going to move this root negative 1 here, times root 7. And that's going to, 10 times 2 times 3 is going to give us 60, my bad, I'm tripping, 60, and then the square root of negative 1 is just I, and then we multiply by root 7. So this is going to be our answer. Okay, and you can use that same strategy over here. You know what, actually, let's do this one together because it does have an I. Okay, so first we try to break down root 48. You know what, let's actually multiply these two roots together. So I'm gonna, since we're multiplying these two together, we can use the associative property. So it does not matter what order we write everything in. We're eventually going to multiply everything together. So I'm going to say 2 times 5 times I times, and then we have negative 48 times 2. So we would have the square root of negative 96, but I'm going to write 96 and then multiply by the square root of negative 1. Okay, great. Now, what I would do is let's try to simplify 96. So, what are some factors, perfect square factors of 96? Well, 16 is a factor of 96, so I'm going to factor that out. We have 2 times 5 times I times root 16. root 16 times 6 is 96. So we're going to do times root 6 times root -1. Okay, and root 16 is going to be 4. So I'm just going to put that in that place. Times, I'm writing this kind of weird. Actually, very weird, as a matter of fact. Okay. But here, actually, in this step, instead of writing root -1, I'm going to write I. And then let's multiply this out. 2 times 5 is 10. 10 times 4 is 40. So we're going to say 40. Now we have I times I. So we've already done all these three. We have I times I. Well, I times I is I squared is root -1 times root -1. So that's root -1 squared. What does that equal? Well, we're squaring a square root, so they cancel out, and it's just -1. So actually here, I'm going to put a negative sign. Let's see, sorry. -40. And then we still have this root 6. Okay, perfect. Let's circle this. Now, we can dive deeper into squaring and cubing and raising I to an exponent. So we just said I squared is -1, right? Well, what's I cubed? Well, that's I squared times I. So that's I squared is -1. And so we're going to multiply by I, which is root -1, which is just I. So we're going to have -1 times I. It's just going to be -I. Now, I to the 4th is I to the 3rd times I. So that's going to be -I times I. That's negative root -1 times root -1. And that's just going to give us, right, root -1 times root -1 is -1 times the negative. It's just going to give us 1. So we have +1. Now we have I to the 5th. And the I to the 5th is just I to the 4th times I. So that means 1 times I, which is just going to be I. And you can see we start back at I. This is the same as I to the 1st, right? Oops. This is the same as I to the 1st. So we start back at our original point, and we just keep on going in a cycle. So since our cycle is in groups of 4, right, we have 1, 2, 3, 4, then we start over again. Let's see how many multiples of 4 fit into each of our exponents. So for example, in I to the 12th, we have 3 groups of 4, and it goes in exactly evenly. So we know, since there's no remainder, that we're going to end at this 4th point, which is just equal to +1. In this case, where we have I to the 27th, we can fit 24 as a multiple of 4, 6 times. And then we have 3 extra. So we have 1, 2, 3. So I to the 27th is just going to be equal to I to the 3rd. And that's going to be -I. In this case, where we have I to the 441st power, we see 440 is a multiple of 4, and then we have 1 extra. So we start at this initial point where it's just I to the 1st, or just I. And then in this case, we have I to the 2022 power, and we know 2020 is a multiple of 4, and then we have 2 extra, so that's going to be equal to I squared, which is -1. Okay, hopefully that makes sense. This can be sort of a tricky topic to some people, so if you do have any questions, just please ask me, come to me, go to Mr. Whitaker, go to the tutoring center, get help, seek resources so that you can fully understand this concept. Okay, let's move on to simplifying complex numbers. So we just want to keep in mind that when we're writing complex numbers, we want it to be in the form of a plus bi. So our imaginary term is going to be our second term. And also, we're just going to, throughout this entire page, we're going to work on addition, multiplication of terms including I. And we also want to always simplify higher powers of I. So if we have I squared, that's equal to -1. And we like having a negative sign out in front rather than saying I squared. Okay, so let's start with this first problem. We're going to add these two. So I'm going to just combine like terms. Really, in this case, we're not subtracting. We don't really need these parentheses. So I'm going to do -1 plus 3. Right, we're combining like terms. -1 plus 3 is 2. And then I'm going to do 2i plus 3i. That's going to be the same as 5i. And it's that simple. We don't really have to do all that much. In this case, we have 2 minus 3i minus, in parentheses, 3 minus 7i. When we have a negative sign out in front of a parentheses, we always want to be careful. So I'm going to distribute that negative sign. So it's -3, and then it's going to be plus 7i. And now we don't really have to care. We don't care about these parentheses. So we do 2 minus 3, we get -1. And then we do -3i plus 7i. And that's going to be plus 4i. And that's going to be our answer. Great. Okay, now let's do some distribution. So we're going to multiply each term in this parenthesis by 5i. So -2 times 5i is going to be -10i. And then we're going to do 5i times I. So that's going to be plus 5i squared. Well, we said up here we want to simplify higher powers. We also said I squared is equal to -1. So instead of saying I squared, I'm going to say -5. So this would be this, -10i minus 5. Now, we also, our first thing I said was we want to write it with our imaginary term being our second term. So I'm going to rewrite this as -5 minus 10i. Perfect. Okay, now let's do number 4. Here we're going to basically FOIL this like we would a quadratic. So what's 7 times -1? That's going to be -7. And then we're going to do positive 7 times 2i. So that's plus 14i. Then we're going to do -4 times -1. That's going to be positive 4i. Then we're going to do -4 times 2, or -4i times 2i. So that's going to be -8i squared. Let's combine like terms. So we have -7 plus 18i from these two terms. And then I squared is equal to -1. So we're going to flip this sign out in front so that it's plus 8, right? Because this is just -1. And then we can combine like terms here. So negative 7 plus 8 is just going to be positive 1. So we do 1 plus 18i. Great. With our imaginary term being our second term. So you can sort of use this to help you with this quadratic. But let's do this cube together, okay? So first, I'm going to actually do, instead of, I know it's cubed, actually I probably shouldn't leave it. I'm going to actually write this out to the side because I feel like this is going to be a lot of work. Let's do 1 minus 3i times 1 minus 3i, okay? You know, let's just keep this here. But we're just going to focus on these two right now. So 1 times 1 is going to be 1. We should put this in parentheses. Now 1 times negative 3i is going to be negative 3i. Now we have negative 3i times 1. This is going to be negative 3i. Negative 3i times negative 3i is going to be positive 9i squared. Now, I could say, or you know what, let's just write this in right now. Positive 9i squared, but I squared is equal to negative 1, right? So let's just fix that right now. Put a negative sign out in front. That way it's simple. And we still have all of this multiplied by 1 minus 3i. Now, let's just combine like terms and simplify all of this. So 1 minus 9 is going to be negative 8 minus 6i. And all of that is multiplied by 1 minus 3i. Okay, great. Now, let's use the distributive property and FOIL this. So negative 8 times 1 is negative 8. And then we have negative 8 times negative 3i, so that's positive 24i. Then we have negative 6i times 1, so that's negative 6i. And then we have negative 6i times negative 3i, which is going to be positive 18i squared. I squared is just negative, so I'm going to say negative 18. Then we can combine like terms. So negative 8 minus 18, that's going to be negative 26. And positive 24i minus 6i is going to be 18i. Perfect. And that's our answer. Okay. Now, let's do number 7. So instead of writing squared, what I'm just going to do is I'm going to rewrite this equation, though it's kind of hard to write, it's so small. Okay, so first let's do 5/4 times 5/4. Well, we multiply the numerators and the denominators, so that's going to give us 5 times 5 is 25. 4 times 4 is 16. Now we do negative 3/4 I times 5/4. So we just did that. Now let's do this. So that's going to be minus 3 times 5 is 15. 4 times 4 is 16. I. We're just going to do this exact same thing here. We know that's going to give us the same value. And then we do negative 3/4 I times negative 3/4 I. So that's going to be positive 9 over 16 I squared. And I squared is just negative 1. So we're going to say minus 9 over 16. So let's combine like terms now. 25 minus 9 is going to be 16. 16 over 16 is 1. And then we have minus 15 over 16i. Minus 15 over 16i. So that's going to give us minus 30 over 16i, which is, we can simplify. 30 over 16 is going to be 15 over 8, which is going to be, just 15 over 8. We can't simplify anymore. Sorry about that. Okay, perfect. Hopefully that makes sense. Some of this stuff I'm not writing everything out. Hopefully you can hear my thinking process because I'm saying it out loud. But if you do need to pause, just pause. Okay? Perfect. And this other number 8 should be pretty similar. Just keep in mind when we're doing when we're doing root 2 times another root 2, that would just be positive 2. And when we do root 2 times 3, that's just going to be 3 root 2. We can't simplify that. Okay, perfect. Now let's work on rationalizing the denominator. So in our last lecture, we had square roots on the denominator. And we need to get those out because we don't like square roots on the denominator. Well, we don't like I on the denominator either. And so we're going to do the same thing by multiplying by the conjugate. And so last lecture, we said the conjugate was basically going to be the same term, except we're going to have a negative instead of a positive. Or in the case of it's already subtraction, we're going to do addition instead. And that's going to cancel out that middle term. If you're still unsure of what I'm saying, go back to that last lecture. We talked about it for a second over there, and I showed you an example. So I'm going to multiply, in this case, by 1 minus I over 1 minus I. And write 1 minus I over 1 minus I is equal to 1. Right? They're the same value on the numerator and the denominator. So we're not changing the value of this left part, 2 minus 7i over 1 plus I. We're just changing how it's represented, okay? So here we're going to have to FOIL. So we're going to just put parentheses around this. 2 times 1 is going to be 2. Then we do negative 7i times 1, which is going to be negative 7i. Then we have to do negative I times 2, which is negative 2i. And then we have negative 7i times negative I, so that's going to give us plus 7i squared. But we have I squared, which is equal to negative 1, so we're going to do negative 7. And all of that is going to be over, 1 times 1 is 1. And then we have I times negative I, which is going to be negative I squared, but I squared is negative 1, so we're going to do 1 plus 1. Okay, right, I'm not accounting for that middle term because I know it's going to eventually cancel out, because I do 1 times I, we get positive I, and then we do negative I times 1, negative I minus I is 0, so we know that cancels out. Okay, so let's combine like terms up on this numerator. 2 minus 7 is going to be negative 5. And then negative 7i minus 2i is going to be negative 9i. And all of that is going to be over 2. Perfect. Now let's jump around to another problem. Let's do this one down here. Let's do 12. Okay, so here I'm going to multiply by the conjugate. So the conjugate of negative 3 minus 3i is going to be negative 3 plus 3i. So that's going to be, I feel like you have to write so small here. Okay. Hopefully you can understand my handwriting. Okay, so again, we have to FOIL these two. Negative 3 times negative 3 is 9. negative 3 times 7i is going to be negative 21i. 21i. And then we're going to have negative 3 times 3i, which is just going to be minus 9i. And then we have 7i times 3i, 21i squared. And I squared is negative, so we're going to do minus 21 over negative 3 times negative 3 is 9. And then 3i times negative 3i is going to give us negative 9i squared. And I squared is just negative 1, so we actually do plus 9. We combine like terms on the numerator. We get 9 minus 21, which is going to be negative 12. And negative 21i minus 9i is going to be negative 30i over 9 plus 9, 18. Here we can simplify. We notice all of these are going to be divisible by 6. So I'm going to write negative 2 minus 5i over 3. That's going to be our answer. Okay, perfect. Same rules should apply in all these other problems. Yeah, perfect. Okay, now let's do some practice. So I comes up when we're doing the quadratic formula. So for example, up here, this very first problem, we could not find the x-intercepts because there are none. But there are solutions. They're not going to be real in this problem. And we can't factor this equation, right? Because it's just impossible. But what we can do is plug it into the quadratic formula. So whenever you're stuck, and this goes for whether your solutions are going to be imaginary or not, whenever you're stuck on factoring a quadratic or finding the solutions of a quadratic, just use the quadratic formula. It's always going to work 100% of the time. And so remember, our quadratic formula is negative b plus or minus the square root of b squared minus 4ac over 2a. So we're just going to plug in our values for a, b, and c into this formula to find our solutions. And remember, our value for a is our coefficient for our x squared term. Our b is our coefficient for our x term, and our c is our constant we add on the end. So in this case, maybe let's just write this out. For this first problem, a equals 1, b equals negative 6, and c equals 12. Okay, let's work with that. So let's plug each of these values into the quadratic formula. So negative b would be negative 6, which is positive 6. So we do 6 plus or minus. Now negative 6 squared is 36 minus 4ac. So 4 times 1 times 12. So that's going to be 4 times 12, 48 over 2a. A is 1, so it's just going to be over 2. So we have 6 plus or minus the square root 36 minus 48 is negative 12 over 2. Now we can simplify negative 12, right? Let's actually do this up here. The square root of negative 12, I'm going to write what's our square root or perfect square factor of 12? Well, that's going to be 4. Then we still have 3, or let's do negative 1. And then we have root 3. 4 times 3 is 12. We have that negative. Square root of 4 is 2. So I'm just going to rewrite all this. Square root of 4 is 2. We have that I from here. Then we still have that root 3 all over 2. So it's eventually going to simplify when we divide by 2 to 3 plus or minus I root 3. Okay, great. And you just use that same exact strategy for each of these two. Now we can also solve by square roots. This is a little easier, but it won't. Sometimes you'll have to use the quadratic formula. And in this case, we can just move this 6 over. So now we have, negative 36 equals 2x squared. So x squared equals negative 18. And we just take the square root, both sides. So we're going to have x equals, and in this case, perfect square factors of 18 are going to be 9. Let's write this out because I think it's important to write it out. Negative 18. So I'm going to say I'm going to say 9. I'm going to pull a 9 out of that. We also have that root negative 1. And 9 times what equals 18? 2. So I'm going to say plus or minus, because the square root of 9 is plus or minus. So plus or minus 3i from that root negative 1, root 2. Great. Let's do we have any more? Let's do this one. You know what? Let's do this middle one actually. So let's move the 7 over. So negative 19 plus 7 is going to be negative 12. And you know what? While we're at it, let's multiply by 3 to get rid of this 1/3. So we have negative 36 now is equal to x plus 3 squared. We take the square root of both sides. We get x plus 3 equals, now the square root of negative 36. Well, the square root of 36 is just going to be 6, but we have this negative, so we have to say 6i. So remember that plus or minus, because the square root of 36 is plus or minus 6. And now we just move this 3 over. So we have x equals negative 3 plus or minus 6i. And all of this is written with our imaginary term being our second term. Okay, I know I went fast on this lecture and some things I did not write all the way down. So if you do have questions, because as I said in the very beginning, and imaginary numbers are kind of an elusive concept that can be hard to wrap your mind around. If you do have questions, go to your teacher, go to Mr. Whitaker. Please reach out to me with any questions you have. Use me as a resource. Go to the tutoring center. Get help from your peers, your classmates who are feeling good about this, who are particularly strong. And just use the internet. There's loads of resources on it. Okay, great. See you later. Have a good day.